In section 8.1, I went over linear inequalities. Today, in section 8.4, I will discuss solving compound inequalities. Okay, there are two kinds of compound inequalities. The first one is the AND compound inequality. So for example, if you say 3 is less than 4 and 4 is less than 5, this is what we call a compound, an AND compound inequality. When we use AND, both of these statements have to be true. 3 has to be less than 4 and 4 has to be less than 5 for the whole statement to be true. Just like if you say, I am a full-time student and I'm 25 years of age. So when you use AND, that means you have to be full-time students and you have to be 25, otherwise you're not truthful. So same thing here. And you can write this as a single compound inequality like this. The 4 is a common number, you bring it down once and you copy everything else. And you still read it as 3 is less than 4 and 4 is less than 5. Or you can say 4 is between 3 and 5. Now in general, you can say 3 is less than x and x is less than 5, and you can write it as 3 is less than x less than 5, which means every real number between 3 and 5, graphically speaking, you're starting at 3, you're ending at 5. You're not including 3 because it doesn't have the equal sign. You're not including the 5, same thing. So that's why you're using parentheses. And every real number, and there's billions of numbers between 3 and 5. And using interval notation, you start at 3, you end at 5, and you put a comma to include everything in between. There is the OR inequality, the OR compound inequalities. If you say 3 is less than, or if you say x is less than 3 or x is greater than 5. So one of them has to be true, or they both could be true, but one of them has to be true for the whole statement to be true because you're using OR. And graphically speaking, this means x has to be less than 3. So that includes every real number to the left of 3, or greater than 5, every real number. So that's your graph. So if you say put a 0, 0 is less than 3, so it's true. I don't care if it's not greater than 5. One of them has to be true. If you put a 6, although 6 is not less than 3, but it's greater than 5, so it's a solution. Okay? So a solution is any number that satisfies one of these. It doesn't have to satisfy both of them in this case because of the OR statement. The interval notation for this, there's two intervals, negative infinity up to 3, and there's 5 up to infinity, and we put an OR in between, and in mathematics we use U for union, okay? So for example, if I say solve the compound inequality, negative 4 is less or equal negative 2 times x plus 8 is less than 8. So we want to isolate x in the middle. There's left, and there's middle, and there is right side. So you want to isolate the x in the middle, so you distribute, you get negative 2x, negative 2 times 8 is negative 16, and then bring everything else down and focus on here. So you want to add a 16, but since there's 3 sides, you want to add 3 16s, 1 to each side. Negative 4 plus 16 is 12. Negative 2x in the middle, and that's 24. And now since we want to isolate x, we want to divide everything by negative 2. And remember what we said in 8.1, if you divide, the inequality will have to be flipped. There's 2 of them, so both of them have to be flipped. 12 divided by negative 2 is negative 6. This becomes an x. 24 divided by negative 2 is negative 12. To graph it, remember negative 12 is to the left of negative 6. So this is negative 6. And this is negative 12. So we're going to include everything between these values. At negative 6, we have a bracket. And at negative 12, we have no line. So it's a parentheses. And using interval notation, you're starting at negative 12, ending at negative 6, including negative 6, but not negative 12. So let's see an example about OR statements. Number 42, page 652. 42, page 652. So we have to solve the OR compound inequality. 3x plus 4 is less than negative 2, or 3x plus 4 is greater than 10. So when it's an OR, leave it split up. Don't try to put it together, okay? So we want to work out the two problems independently. 3x, so we're going to subtract the 4. 3x is less than negative 2 minus 4 is negative 6. When we're done, we'll come back to the second one. We're going to divide by 3. We're not flipping the inequality because we're dividing by positive 3. Same thing here. We subtract the 4. 3x is greater than 6. Divide the 3. X is greater than 2. And it's an OR. So to graph this, x is less than negative 2, so we start at 2, not including it, shade everything to the left of negative 2 all the way to negative infinity, and then greater than 2, start at 2 all the way to the right, and this is your solution set using interval notation, negative infinity to negative 2, or 2 to infinity. Alright, let's look at page 652, number 52. In your text, page 652, number 52. Okay, so solve the compound inequality, number 52, page 652. 0 is less than x, or 3x minus 5 is greater than 4x minus 7. So this is already isolated. Now let's work on this. We want to add the 5. 3x is greater than 4x minus 2. We want x to be on this side, so subtract the 4x. Get negative x is greater than negative 2. Divide by negative 1. So basically we have 0 is less than x, which is the same thing as x is greater than 0. I always like to put my x letter on the left. Or x is less than 2. So 0, x is greater than 0, or x is less than 2. So you can see that includes the whole number line, right? If x is greater than 0, you're getting all the positive numbers. If x is less than 2, you're getting all the numbers to the left of 2. So that includes all the negatives also. So your solution is actually the whole number line, right? All the positive are the solutions. All the less than 2 numbers are solutions. So it's all real numbers are solutions, okay? See, when you have OR, you have to include everything, whether it's in this or in that. If it's an AND, you have to include where they overlap. So AND means where they overlap, OR means everything in both of these. Let's look at 68 from page 652. We have a over 2 plus 7 over 4 is greater than 5, or 3 over 8 plus a over 3 is less or equal to 5 over 12. So let's look at the first one. In the first one, we gotta get rid of the fractions by timesing everything by 4. And we're not flipping anything because 4 is positive. 4a over 2 is 2a. 4 times 7 over 4 is just 7. Is greater than 4 times 5 is 20. Subtract the 7. That's greater than 13. Divide the 2, greater than 6.5. If you look at the second one, we're going to times everything by the LCD. 12 is not good. 24 times by 24. So 24 times 3/8. The 8 divides the 24 3 times. 3 times 3 is 9. 24 times a over 3 is 8a. And then 24 times 5 over 12. What's 24 times 5 over 12? It's 10, because the 12 divides the 24 2 times. 2 times 5 is 10. Subtract the 9. 8a is less or equal 1. And divide by 8. A is less or equal 1/8. So we have a is greater than 6.5 or less or equal to 1/8. 2, 3, 4, 5, 6, 6.5. And it's greater than, so this goes to infinity. 1/8, it's less or equal, goes to negative infinity. So you have negative infinity to 1/8, including 1/8, or 6.5 to infinity. And that is it for 8.4.